Today on Kapechi's Corner, we're going to do a review of multiplying polynomials using FOIL and also factoring polynomials. Now, this is an Algebra 2 course, so you've done this in Algebra 1. So this is more of just a review, just to kind of refresh your memory. You are going to need both of those skills throughout your math career. So let's look about multiplying two binomials. There are two methods. Okay, so the first one is we're just going to distribute. So I take x times x plus 2 plus 7 times x plus 2. And I get x squared plus 2x plus 7x plus 14. Combine my like terms, and I have x squared plus 9x plus 14. Okay, now the way that many math teachers do it is FOIL. That stands for first terms of each binomial outside of the whole thing, like these would be outside right here. And then we're going to do inside, again, our inside terms there. And then our L stands for the last terms of each of the binomials. So it is a way of distributing it, just going by it a different method. So again, first is x times x, which is x squared. Outside is plus 2x. Inside is plus 7x. And our last is plus 14. Combine our like terms, and I have x squared plus 9x plus 14. So as you can see, we get the same answer. It's just a matter of the method that you would like to use. When factoring, always look for a GCF or greatest common factor to factor at first. The expression may or may not have one. So I'm going to look at both the numbers, which are the coefficients, as well as our variables. So out of a 4 and an 8, a 4 can go into both. A squared and A, I'm going to take the lowest power, which is A. So I'm left with 4A, and then I get A plus 2. Now, you can check your work by distributing back in if you want. So I have 4A squared plus 8A, which is what I started with. Okay, we'll do the same thing for number 2. Now, again, I have a 9 there, but I don't have a 9 in my second expression, so I can't factor out a number there. I just have to look at my variables. I do have a C, so I'll pull that out. And I do have a D to the second, D to the third. So D to the second is going to be my highest. Now, if it helps you, some students find that if they rewrite underneath what they're factoring out visually, that just kind of helps them. So for number 2, when I factor a C and then D squared, I'm only left with 9. And then I have a minus, and I'm left with the D there. Now, one thing you have to pay close attention to is if I started with the binomial here, this is a binomial, whatever is in the parentheses should also be a binomial. Okay? Again, I can check my work if I want. This gives me 9CD squared minus CD cubed, which is what I started with, so I know I'm okay. Okay, we're now going to look at factoring a trinomial, which is 3 terms, to 2 binomials. Okay, so the first thing we're going to do is we're going to check out if we have a greatest common factor. If we do, we'll factor that out just like we did. And then we need to determine the signs of the binomials. So we're first going to look at our last sign there. Okay, if that's positive, it means that the signs are the same. They're either going to be both positive or both negative. That depends on the sign that's there. Or if this value here is negative, then I know I have opposite signs. Okay, and then we're going to play around with the numbers. We're looking at factors, things that I add together. And again, you can always use FOIL to check your work. So let's look at number 3. We don't have a greatest common factor, so I like to set my binomials up right away. This sign is positive, so it tells us that the signs are the same, so they're either both plus or both minus. Because that is plus, we know that they're both going to be plus. Okay, the only way I can get to x squared is x and x. Factors of 6. 6 times 1, 3 times 2. Because the signs are the same, I'm looking for factors of 6 that add up to get 5, so I get 3 and 2. Now again, if I want, I can check using FOIL, and we won't do this for all of them, but we can for each problem if you wanted to. Great idea on a test. X squared, my outside is plus 2x, my inside is plus 3x, and my last is 6. Combine my like terms, and I have what I started with, so I know my answer here is all set. Moving on to number 4, this time our signs are going to be opposite. So I'm going to set up my parentheses. Now I don't know where that plus and minus are going to go yet, so I'm just going to hold off on that. I'm going to wait. Factors are 20 in the beginning. That's going to be tough. So it's either going to be 20 and 1, 10 and 2. I might also use 5 and 4 because I don't know which factors I'm going to use that. I'm just going to wait. I'm not going to put those in. However, this 3 I know is a prime number. So I know I have a 3 and a 1. And now I can play around with the numbers. Now I'm going to use 5 and 4. So I'm going to put the 4y here and the 5y there. And sometimes it's just kind of a trial error if you don't see it right away. So I like to do these little loops. My inside's going to give me 15y. My outside gives me 4y. Now when I subtract them, I know I get 11y. So that kind of just helps me. So I don't have to check the whole thing using FOIL. Now the one issue I have is where does my plus go and where does my minus go? Well, this 15 is the higher of the two, right? The other one's 4y. I need that to be negative since I have a negative 11 up here. So I'm going to put that negative here, and I'll put that positive there. And again, I can check using FOIL if I want to. Okay, moving on to another, version of some trinomials we see. In this case, we see binomials, different of two squared. Some people call it dots, different of two squares. So what that means is I have a perfect square minus a perfect square. I say that a lot. I have a perfect square minus a perfect square. When we know that's the case, we're going to have the same exact binomials with different signs. So we're going to take the square root of a squared, and that goes in our first term, and our square root of b squared, and that goes in our last term. Okay, again, you still always look for greatest common factor if you have one. So x squared minus 4. X squared is a perfect square because it's x times x. 4 is a perfect square because it's 2 times 2. So I can factor it. I have an x and x here. I have a plus and a minus, right? The signs are the same. Square root of 4 is 2. And there we go. So again, I'll check this one using FOIL just so you can see what happens here. Because the binomials are exactly the same, except for the sign, these middle two terms will zero out, which is how you get x squared minus 4. All right, let's look at the next one. 16y squared minus 81. Again, no greatest common factor. 16 is a perfect squared, so is y squared, and so is 81. Square root of 16y squared is 4y. And my plus and minus. Square root of 81 is 9. Oh, is 9 and 9. And that's it. And again, you can check that using FOIL if you'd like. All right, perfect square trinomials. Most teachers I know do not teach this formula just because it's a lot to remember. It's just a lot easier to use FOIL, but it does exist. So for instance, if you're giving a trinomial in which the first term is a perfect square and the last term is a perfect square, and if you were to take the square root of those, multiply it by 2, you would end up with something like this. Then you're all set. So for instance, looking at here, I notice that x squared is a perfect square, 16 squared is a perfect square, square root of x is x squared is x, square root of 16 is 4. Multiply that by 2, and I have this middle term here, so I can actually just go right to that. That's just a lot of remembering for me. I think it's just easier just to factor it. If you have the same binomial written twice, you just rewrite it. Okay, so let's look at number 7. I'm just going to factor it. My signs are the same. They're both positive. I have 4. 4 can be 4 and 1 and 2 and 2. 25 could be 25 and 1 or 5 and 5. I'm looking for combinations that when I add together, I get 20. So I already know that 25 and 1 isn't going to work. So if you play around with the numbers a little bit, you get 2x here, 5, and 5. Now again, I can use my loops. I have 10x on the outside, 10x on the inside, which is I have 20, which is what I was trying to get. So now, once I know I'm okay, I do have the same exact binomial. So I'm just going to rewrite it as this, 2x plus 5, quantity squared. That would be your final answer, and that's what you see a lot on multiple choice questions. All right, number 8. I have to be careful here because I do have a greatest common factor, so I'm going to take out a 2, and I'm left with 4b squared minus 12b plus 9. Okay, so again, I'm going to factor, and I'm going to have to bring down that 2. I can't lose that 2 along the way. The signs are the same. They're both negative because that's a negative. Again, I'm playing around with my factors. I have 2b and 2b, and I have 3 and 3. Okay, so how am I going to write that? I have to, again, bring down that 2. That doesn't disappear. My binomials are the same. So I'm going to rewrite it in squared, and that's my final answer right there. All right, so let's just practice some factoring. Again, if you want to pause the video, try them, and then you could even fast forward and look at the answers. That's up to you. Okay, so again, in number 9, I don't have a greatest common factor. I have B and B. Signs are the same. They're both in negative. So I'm going to use 3 and 2. Now, again, a question students often say, does it matter if I write B minus 3 times the quantity of B minus 2? No, that's okay. You can switch the order. Just make sure whatever the sign is inside is traveling with that binomial if you happen to have different signs. All right, number 10, no greatest common factor. K squared is going to give me K and K. Again, I have opposite signs, so I have plus and minus. 7 times 5 when I subtract is going to give me to 2. I want it to be negative 2, so I need that higher factor to be the negative. So that's going to go here, and then I have K plus 5 there, and then I'm all set. Again, you can check these using FOIL. Now, in looking at number 11, I have x squared, which is a perfect square, and 64, which is a perfect square. But remember, to use my difference of two squares, it needs to be a perfect square minus a perfect square, which it is not. So this is actually, we don't have a pattern for this. This won't work. So this is actually not factorable. Okay, last one for today. Number 12, we have a lot going on there, so we need to be careful. We do have a greatest common factor, so if I look at 5 and 10 and 40, I'm going to factor out of 5. And then I have d to the 8th, d to the 7th, d to the 6th. I have to factor out my lowest one is d to the 6th. So then I'm left with d to the 7th minus 2d minus 8. Okay, so from there I can factor, see if I can factor a little further. Bring my monomial down there, my greatest common factor. I have d and d. I have a plus and a minus. Factors of 8 that I subtract to get 2 is going to be 4 and 2. Again, this sign is negative, so I need that sign to be negative. So I'm going to have a 4 here and a 2 here. And that's my final answer. All right, hopefully this helps with refreshing your memories on all of these topics you're going to use a lot in math going forward. Okay, great job. Have a good day.